And welcome back. So this is the second part of Unit 1, Lesson 4. We need to talk a little bit about something that we call the metric system, or more specifically, the SI system, the International System of Measurement, which is what this is. So once upon a time, a lot of scientists did things differently. So some people might have written numbers a very specific way in one country and written numbers a different way in another country, and that got to be confusing. So around 1960, a bunch of scientists got together in France, of all places, and they figured out a way to replace the archaic metric system with one numerical universal language. Now, let me try to explain something. There's some other nuances that we don't need to really go into for chemistry class, but for our class, this is the big one. In the United States, this value is 75,000. In the United States, this value is 75,000. But in many other countries of the world, they use a comma as a decimal. So in some countries, this value right here is 75. And that's not that big of a deal if you're just kind of like talking to people. But if you're like really doing a lab or you're doing something that's kind of important and you get to the point where you need to communicate numbers and you want that person to use 75,000 and they see it as this and they think it's 75, that can really mess things up. So the fix was we only use decimals when there actually is a decimal, and we use spaces like this to indicate like big numbers. And so in my class, you will see me write numbers like this, 75 space 0000, and that's just the way because of how I was trained. I don't really care if you write a comma. I don't really care if you put it in the space. I don't really care if you squish it all together, but I'm just telling you that that's why you see numbers like this in our class. Now, the other thing that's important to note is that the metric system or the International System of Measurement is based on powers of 10. Now, there is a video that I will put in the notes or in the Google link or Google Classroom to this video about the powers of 10, but I don't want to do that right now because that'll be a long video. It's like 9 minutes and it's interesting and I think you should watch it. But so I think you should definitely watch on your own time. So what I'm going to do is I'm going to pause the video here and have you go click on that link and watch the video. All right, we're back. There are 7 base units in the metric system or in the SI system that we use in science. There is the meter, which we measure length with. There is the kilogram, which we measure mass with. There is the second, which we measure time with. There is Kelvin, which we measure temperature with. However, in our class, we'll probably use degrees Celsius more than we'll use Kelvin. There is the mole, which is what we measure amount of matter in. There's the amp or ampere, which is what we measure electricity in. And then there's the candela, which is what we measure light in, more specifically bright light, like how bright a light is. So these are the units that you're going to be responsible or that you should be exposed to. But the ones that we're going to spend a lot of time with are mass, temperature, and matter or amount of matter. Okay, those are the ones that we're going to spend the most time with in this class. Okay. So the other thing that you should be at least familiar with is what these prefixes mean. So we have this idea of a base unit, which is one of something. It's like 1 meter or 1 gram or 1 liter or 1 second. But if we put a prefix in front of it, we can have a kilometer, which means a kilometer is 1,000 is the distance of 1,000 base units, which is a meter, right? We could have a megameter, which is a distance of 1 million base units, which is the meter, right? And we can have a gigameter, which is the same thing. It's not 1,000, 1 million base units. Sorry, the gigameter is 1 billion base units. So like that's what those prefixes tell us. And we're going to work with that in a worksheet in the future. We also have numbers that are smaller than 1. So we have things like the decigram, which is a number that's smaller than 1, and we have the centigram, which is a number that's 0.01 of a base unit. We have the milligram, which is 0.001 of a base unit. With the microgram, which is 0.00001 of a base unit. And then we have the nanogram, which is like super tiny, 0.000000001 of a base unit. We're going to work with these and practice with them going forward, but I just wanted to expose them to you now. So at this point, we have now concluded part 2 of Unit 1, Lesson 4, and you should